All right, AMP Honors Platform. We are back today with CEO and President of Surfacide, Jeff Veenhuis. As you guys know, this month is UV Awareness Month, so who better to talk to than the man himself and get a little bit more information on UV light. So how's it going today, Jeff?
Going great, Brandon. Thanks for having me.
Yeah, thank you very much for doing this. So we'll get right into it. What type of UV rays are actually used to disinfect?
So yeah, the UVC spectrum is what we utilize, and specifically within the C spectrum, which ranges from about 180 nanometers to about 280 nanometers. We use specifically a 254 nanometer spectrum of UVC, which is ultraviolet C. The sun actually is the ultimate UV source, and the sun gives off UVA, UVB, and UVC. The UVC is all absorbed by the ozone layers in the upper atmosphere. The UVA comprises the majority of what comes down through to the earth, and then a little bit of UVB. No living organism has a defense mechanism to the UVC, which is why we use it as a germicidal energy.
Awesome. That's very interesting. So these rays are dangerous to everybody since nobody has a defense mechanism against it. So these are dangerous to humans as well, correct?
They are, and human and I guess living cells absorb what is the ionizing radiation. And the way our mechanism of action really is that it breaks apart some of the protein bonds at a genetic layer. So they're called thymine dimers. And these are things that are in essence scar tissue that build up between the protein bonds of the genetic material. Once there is enough damage to these, they've exceeded their resistance to that, and they are no longer capable of replicating. Once there's enough of those cells that have been damaged so they can no longer replicate, it renders the pathogen or the microorganism as eradicated and dead. And so for humans, what we would feel most are the two areas of our body that are most susceptible. It wouldn't immediately kill us. It's not certainly that strong, but what it would do is damage our skin and our eyes. The eyes really absorb that UVC spectrum. So it would be akin to like a snow blindness or a welder's lamp. To our skin, it would be like a severe sunburn. And so wherever we're using this, whether in an environment or in a room, or now even outside of healthcare, we take every precaution to keep that area unoccupied so that we don't get an avoidable UVC exposure and cause somebody to have those issues.
Yeah, so can you elaborate a little bit more on how or why you guys went about harnessing the light and containing it, all the precautions you take, and being able to keep people safe?
Yeah, so we started as a healthcare modality and technology, and in particularly in high intensive care spaces within healthcare facilities or hospitals. And so as people are ill and as they're in the hospital, one, there's a greater degree of what we call bioburden or risk of all these pathogens. One you may have heard of is MRSA or MRSA, methicillin resistant Staph aureus, Clostridium difficile or C. diff, and many of these other organisms and pathogens. What we were attempting and have been successful in doing is showing that we can reduce that bioburden such that the risk of transmission from the environment is greatly reduced. When there's less bioburden, there's less risk of transmission from a staff or a healthcare provider or from a patient or from a family member to a patient. And so where we began in the healthcare world, where we're now moving to amidst the pandemic, is the SARS-CoV-2 is still viable in the environment. And so by our exposure of all of that bioburden with SARS-CoV-2, by eradicating and eliminating it, it's no longer a threat for transmission. And so we can't eliminate all of it. One of the real limits to UVC is that it has to be in direct line of sight. And each different organism type has a different and varying resistance to the amount of dose it takes to eradicate it. What we do know is in the hierarchy of organisms, the enveloped virus, like the coronavirus SARS-CoV-2, are highly susceptible. It takes a momentary exposure to eradicate SARS-CoV-2 with UVC energy.
Wow, that's very interesting. Can you elaborate a little bit more on comparing UV light and the disinfectant ability of it to maybe some of the chemicals that were previously used?
Sure. So chemicals are still very viable and widely used. They bring with them trade-offs, right? So every modality has pluses and minuses. The one that we have that is a greatest plus is, other than the expense of that capital equipment, what we need to do is maximize our exposure, but we do need to get in direct line of sight. Where a chemical, whether it's in a fog or a liquid or a vapor, can penetrate and widely disperse to more surfaces. But it also has residues, it has an ongoing cost of consumption, it could have some toxicity, it could be corrosive to electrical equipment. It also could take a while once that, whether it's a bleach or a quaternary cleaner or a hydrogen peroxide, it could have a latency or a time that it can't be immediately occupied or exposed for reuse. And so there will be odors and other things with chemicals, but each has their use and they can be complementary. The value to UVC is the speed and the lack of any toxicity or odors. And environmentally, it's also extremely friendly in that we've minimized the power consumption it requires to operate our multiple emitter system. And that's really the only consumption to our system.
Yeah, and I have to imagine that your guys' company has been getting a lot of orders recently with everything going on and just a new option to combat everything you just talked about.
Yeah, we've been quite busy. The excitement is built not just within the U.S. We're currently in about 500 hospitals in the United States, but what's also really fun is the expansion globally around the world. The exposure and the risks and the pandemic has freed up both funding and some research into partners that we've identified and worked with, or in markets that we're expanding ourselves directly into, literally around the world. We've sent a lot to Australia. We have a number going to Saudi Arabia. We've sent some to Oman, throughout Europe and Spain. We have plans to send a few additional systems down to Latin America and South America. So yeah, it's been, I guess what we're happy to do is that we know we have an evidence-based solution. We've been proven that we can eradicate coronavirus. And if we can help the frontline workers, or if we can help business owners or consumers be protected and safe because their environment poses less of a risk, that's a huge thing for us to be a contributor to.
Yeah, wow, that's really incredible. The global reach, I bet, that's when it really starts to get awesome, and you can see the reach just one company can have.
Yeah, exactly.
So for those of you who don't know, Jeff's company Surfacide creates what some may have called UV robots. Do you just want to talk a little bit about what a quote unquote UV robot is and what it does?
Yeah. So I guess for a number of years, a lot of the healthcare facilities, and I think it probably was propagated by a few of the manufacturers, they refer to the towers or the emitters as a robot. And we've kind of shied away from that nomenclature or term because we see a robot as being something that's autonomous or that is a machine that replaces what is done by humans. As of late, there are some autonomous moving UVC systems, and we've evaluated and are currently evaluating that in R&D projects. We use three in the typical space as multiple emitters to have increased lines of sight and angularity to cover more surfaces. And so in a single cycle, our three emitters are covering that entire room space. And we feel that we can actually do so while they are static. They are better engaged with some human interaction and intelligence, and it's actually a much easier workflow and more efficient, and it can be more easily deployed in a variety of spaces. In large airport terminals or gigantic spaces, a Roomba-like robot actually probably is a great solution. But in most small or fixed spaces, we feel that our static multiple emitter approach is far more efficient and much more effective at delivering greater doses of energy in a shorter time with an easier workflow.
Yeah, that's very incredible. For those of you who haven't seen what the Surfacide robots look like, definitely go check it out because they're something that is very interesting and I don't think are going to be going away anytime soon. So the next question that maybe people are thinking at home is this something that I can have in my house? And I know we may not be there quite yet, but when would you estimate that the possibility for a reasonable, affordable system like this for somebody to have in their house to protect
Yeah.
themselves?
So there are a lot of what I would call consumer UV products, many of which are honestly probably not very efficacious or effective. They're just so low intensity. I know the high intensity systems like Surfacide and what we're currently marketing are probably outside of the price range of most consumers today. But as things evolve and as there's greater R&D and then we get economies of scale over the next years, I believe that that is a very good possibility. Or certainly the possibility exists that managed service companies, kind of like many of us do not own a steam cleaner, but throughout the year we'll get our carpets cleaned. There could be services that are offering UVC with some regularity as a deep clean or a terminal type bioburden reduction or disinfection decontamination service. And that could be very applicable to offices, to public spaces, or to home use. So I think the other thing is currently we have not seen the advance of LED technology in a really germicidal spectrum that is low enough in cost and effective in intensity and delivery of dose. But as those advance further, that could be one of those breakthrough type moments that would make it better and more applicable for consumer use.
Yeah, that's a really great thought, similar to a steam cleaning service. So maybe somebody doesn't have one in their house, but they can pay somebody on a schedule to come and really deep clean
Exactly.
their house.
Schools, churches, homes, banks, facilities like restaurants and other hospitalities. Now, we have sold a number of them to either public transportation, correctional facility, essential responders, police and fire. We've sold some to the Space Needle and others. So we have already begun what I would call the early adopters within or outside of healthcare. But we'll see that continue to increase.
Yeah, that's exciting. We'll see. I'd like to see where this is at in 5 years.
Yeah,
Um,
agreed.
so, kind of tracking back a little bit to when you were talking about the effectiveness, um, how long would a typical hospital room or 20 by 20 room take to be disinfected using one of your systems?
Yeah. So I'm going to answer that two ways. In our classic previous kind of modality for decontamination and bioburden reduction, a typical room of that fairly large to medium size is probably 15 to 20 minutes. But that is because we were delivering a significantly higher dose than is required for eradication of SARS-CoV-2. So if the world is really truly just focused on diminishing the risk of SARS-CoV-2, we are in the midst of trying to develop a few studies that can actually very well and independently document what the dose tolerance is of SARS-CoV-2. There are some early reports that have been published of a ridiculously low exposure in the 20 millijoules per centimeter squared. As a contrast, our typical cycle in the healthcare arena is about 1,500 millijoules. So a far lower dose is required for SARS-CoV-2. If that is our true target organism, it could be as short as 4 or 5 minutes to do a fairly large room, 20 by 20, with a very brief exposure to all of those organisms in direct line of sight. The eradication, it's highly susceptible to UVC. So if we want to target all of those other HAI or healthcare acquired infection risks, we would still be in that 15 to 20 minute range. If you just want to target virucidal or SARS-CoV-2, it could be as short as a few minutes.
Wow, that was definitely not the answer I was expecting.
Yeah.
So can you talk about some of the biggest challenges and or successes you've had working with UV light?
Yeah, I mean, we get to be a part in the solution. The healthcare facilities and hospitals, we've been fortunate enough to partner around the world with some of the leading facilities. In Saudi Arabia, actually, a lot of what they were targeting originally when they adopted and looked at Surfacide was the Middle East respiratory syndrome, which is a previous known coronavirus. It really hasn't widely spread into the pandemic like SARS-CoV-2, but SARS-CoV-2 is a cousin to the MERS. And we've seen great results and published data about that eradication in C. diff and others, which are more hospital-acquired infections. We've seen really hospitals experience greater than 50% reduction in their infection rates, and it's in a combination. So it's not all just because of the use of Surfacide, but that Surfacide and the UVC could be that tipping point technology that all their other good cleaning regimens and other best practices, when applied in conjunction with Surfacide, deliver huge results in reductions. I mean, 50 to 60% reductions and greater translate into a lot of avoided illness. They translate into a lot of avoided waste of care and caregivers. And that translates into a big economic win for healthcare providers.
Yeah, that's awesome to hear some of those numbers. So I have one more question for you. I don't want to take up too much of your time. What is the most interesting thing that you have learned about UV light since you started working with Surfacide?
Well, there's a lot of them, and I think one of the most interesting things that has promise into the future is maybe combining spectrums or looking at other spectrum and or developing other modalities that we can deliver UV more efficiently, more quickly, and more inexpensively. And so one of the real hopes that I have is not just to be a developed world technology, but to make it affordable and accessible to the whole world, to make not just American or high, economic countries in healthcare or other facilities be able to be disinfected but to provide these in clinics and in hospitals and in public spaces, public transportation all around the globe. And so how and what we do that, those are the interesting things we're still trying to discover, and those are the things we're trying to do research and development on, how we can do that best.
Yeah, that's really, really great to hear. And I'm, like I said before, I'm excited to see where not only Surfacide, but the whole UV as a disinfectant race will be in like 5 years.
Yeah, we agree. There's a bright, pardon the pun, a bright future, and we sure hope that we can continue to advance with customer feedback and interaction, and as we progress more and more outside of healthcare, how we can make it a usable and a delivered best practice. We look forward to doing that.
And we'll be keeping track of you. So best of luck.
All right,
Well,
sounds great, Brandon.
thank you very much for all of your time and for giving us a little piece of your brain. Hopefully this was educational for a lot of people. I know this is kind of an area that not many people know about or even know that it exists. But I think in the future, it's definitely going to be kicking in the door a little bit. So thank you very much for taking time to be with us.
Thank you, Brandon. Yeah, appreciate it. And thanks to AMP.